So in this particular question, we are told that when the metal wire is stretched, the elastic potential energy stored in the wire increases, and the quantity called stress can be calculated by dividing the stretching force by the cross-sectional area of the wire. So let's just write it down. Stress is going to be equal to force divided by the area. Okay, and so the unit of stress is going to be equal to the unit of force divided by the unit of area, and this means that we have newtons per meters square. All right. On the other hand, we have another quantity called strain, and strain is calculated by dividing the extension of the wire by the original length of said wire. So let's just write it out. Strain is going to be equal to the extension of the wire divided by the original length, and so the unit of strain is going to be equal to the unit of the extension divided by the unit of length. So it's going to be meters divided by meters. Right now, at this stage, I could make a cancellation and say that strain is essentially dimensionless, but I'm not going to do that. What I'm going to do is continue on with the rest of the question first to see what they want. Okay, so the question then says we have a graph of stress and strain. So they ask what is the unit of the quantity that represents the area under the stress strain graph. So they want the unit of the area. So the unit of the area is simply going to be the stress times the strain. Okay, the unit of stress times the unit of strain. So we have newtons per meter square multiplied by meters divided by meters, right? So on our top, okay, in our numerator, we have newtons times meters, okay, and this gives us, of course, joules, all right, because we know that a possible unit for work done, which is essentially energy, okay, is going to be newtons times meters. So we have joules. And in our denominator, we have meters square times meters, which is meters cube. So the best answer for this is thus going to be joules per meter cube, which is D.